Hello everyone, welcome back again to the lecture 16 of our LPP problem, that is and this is the lecture 16, and in the lecture 15 we started the assignment problem. Okay, we just discussed the some theorems and some results of the assignment problem and one examples. Okay, so in this lecture we'll discuss some results and then a traveling salesman problem. Okay, an assignment problem which is known as traveling salesman problem. Okay, so let's start, and before starting I am requesting you to all those who are new in my channel, please like the video, comment if you have any doubt in the comment section below, and subscribe the channel. Okay, and this session is very helpful for GATE mathematics and CSIR NET mathematics also, and the state level set examinations also. Okay, so please like, comment, share and subscribe the channel. Okay, so let's start. So there are 3 and 4 types of assignment problem. Okay, types, you can say here, types of assignments. Okay, so types of assignment problem, you can say types of assignment problem. So one is maximization of assignment. Okay, so what is the maximization of assignment? So if an assignment problem deals with the maximization of the objective function, then obviously the matrix considered is a profit matrix. Okay, such problem may be solved by first reducing to the problem to the minimization problem and then applying the usual technique, that is Hungarian method of assignment algorithm. Okay, this can be done by subtracting all the elements of the profit matrix from the largest element of the matrix. Okay, so this is the maximization maximization assignment. That means what? That means if there is some if there is a profit matrix, then we first choose profit matrix and maximization problem, then we first convert it to the minimization problem, that is cost matrix, and then solve the usual algorithm. Okay, so here one theorem. So the theorem says that let just a minute. Okay, so let Aj equal to Cij be the profit matrix, B equal to Cij, be another matrix defined as this Cij dash equal to P minus Cij, where P is the largest element of Cij. Then the optimal solution which maximize the objective function is equal to Z equal to summation I equal to 1 to J Cj I Cij xj is the optimal solution of the minimization problem. Z dash equal to I equal to 1 to n summation j equal to 1 to n Cij prime into xj. Okay, so this is the theorem, that is we first convert the profit matrix in the to the cost matrix and then solve it. Okay, here the proof is given, you can see it. And number 2 is what? Number 2 is unbalanced transportation problem. What is this? So sometimes assignment matrix is not given in the form of a square matrix. Okay, in today's class, last session, we already said that assignment problem is a square matrix. Okay, that is the number of rows and number of columns, that is there is a one corresponding between the number of from the cells and from the destination. Okay, from the source and from the जो है destinations and the source के बीच में एक one correspondence है. ठीक है, that is there are n city and n salesman, you can say. So such type of problems is called the unbalanced assignment problem. Okay, unbalanced assignment problem. In this case, required number of rows or columns are added to the matrix to make it a square matrix such that all the assignment of those additional rows or columns are zeros. Okay, these additional rows and columns are said to be fictitious or dummy rows and columns. Okay, then number 3 is restricted assignment. Okay, sometimes for technical problem or the space problem, for the other restriction, some jobs cannot be performed by some particular facility. Okay, this type of assignment is called the restricted assignment problem. This restriction is generally indicated by putting cross or dashed or infinity sometimes, okay, in the corresponding cell. Difficulty for the solving such type of problem can be overcome by assigning a very large value, that is m or infinity, those restricted place. Okay, in this class or in this session we discuss a restricted assignment problem, that is a traveling salesman problem. Okay, and number 4 is some costs are negative. If some cost or some elements of the assignment matrix are negative, then add a positive number to all the elements of the matrix so that the modified matrix all elements are non-negative, then solve the problem by the usual Hungarian method. Okay, so this is the 4 types of assignment problem. Okay, and there is a important thing, that comparison between assignment problem and transportation problem. You can see the transportation problem matrix is not necessarily square, but in assignment problem the matrix must be a square matrix. In assignment transportation problem, variable xj may or may not be non-negative integer, but in assignment problem the variable xij must be either 0 or unity, or every row or unity, or every row or every column contains only one unity for xij, and the one and the other values are 0. Okay, in the transportation problem xij equal to ai and summation xij equal to bi, where ai and bi are the not necessarily be unit. Okay, unity, but in the assignment problem each ai and bi must be unit with m equal to m. Okay, now we comes to the traveling salesman problem. So traveling salesman problem says that what this is one type of difficult problems of the time. Okay, मतलब ये जो प्रेजेंट सिचुएशन का बात कर रहे हैं यहाँ पे, a salesman must visit n cities, passing through each city only once, beginning from the one city called a base or starting city and return to it. The cost of the transportation from one city to another is given. The problem is to find the order of the minimum cost, minimum route. Okay, so this is our motto in the assignment problem. Okay, the order of the visiting city is such that all the cost transportation is the minimum. Okay, there are n-1 factorial possible route to visit these cities. Okay, it is difficult us to find the transportation cost all those n-1 factorial. That's why the routes it is impossible to selecting among these which route is minimum cost for transportation. Okay, so our first problem here कुछ सम यहाँ पर लिखा है, ठीक है, आप लोग देख सकते हो. तो दिस इज द मेन व्हाट traveling salesman problem. Okay, now let us take an example. So solve the following traveling salesman problem. Okay, 370. So there are 5 suppose this is a company and there are 5 cities, you can say 5 products, you can say. Okay, so see this here, infinity, 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 infinity given. That means what? That means these are not possible. Okay, these assignment are not possible here in the what, the restricted assignment. Okay, that means what, the sometimes for the technical problem or space problem for other any restriction, some jobs cannot be performed by some facility. Okay, so this is this type of problems we take here. Okay, and see the other cost from A to B, from B to capital, small b to capital C. These are the cost matrix. This is the cost matrix. Okay, now first we what to do? First we subtract the minimum element from each row. Okay, suppose and this infinity here do not change. Okay, because this is a big number. If we subtract some small element from a big number, then it must be infinity. Okay, so we first subtract here this 4. Okay, since this 4 is the minimum element, so 0, then 4, then 2, and then 3, and in this row the minimum element is 5. Okay, so here this is 2, this is 3, this is 0, and this is 1. Okay, then and here in the third row 6 is the minimum element, so this is 0, and this is 2, this is 3, and this is 1. Okay, then the next row, fourth row, this is 5 is the minimum element, this 5. Okay, so and here 6 is the minimum element, here 4 is the minimum element, and here 5 is the minimum element. Okay, so we subtract 5 from each element, so 3, 0, 4, and here 3. Okay, and in the fifth row 4 is the minimum element. Okay, so this is 0, then 2, then 3, then 4. Okay, 0, 2, 3, 4. Okay, so this is the table 1. Okay, then we go to the table 2, that is we operate this same operation to the columns. Okay, so first in the column we write, so infinity, 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 and infinity. Okay, so this is 2, 0, 3, 0. This is same because there are zeros. 2, 0, 3, 0. Okay, and then the second column, in the second column 3 2 0 2, there is also 0, 3 2 0 2. Okay, then the next column, in the next column there are no 0 and 3 is the minimum element, so 2 0, so this is, oh sorry, 2 is the minimum element, so this is 0, this is 1, this is 2, sorry, this is 2, this element, and this is again 1. Okay, then we go to the next column, that is the fourth column, 4 0 3 4, here 0 1 0 we get already, so 4 0 3 4, so this is 4 0 3 and 4. Okay, 4 0 3 4, and in the next 0 1 1 3, so 0 1 1 3, and this is infinity. Okay, so we operate the same operation, that is we subtract the minimum element from each column, for each column, from all, for all the elements. Okay, this is table 2. Okay, next our work is what, we cover all these zeros by the dotted line, so that with minimum number of line. Okay, so this is, we have to cover all the zeros. Okay, so suppose we here take this line, then this line 1 2 0 cover, then this line, and then this line. Okay, so there are 4 lines, but the order of the matrix is 5. Okay, therefore this is not the what, this is not the optimal solution. Therefore we have go to the further process, that is we subtract the minimum element, we uncovered element from all over the matrix and add in the what, and in the this intersection area. Okay, this is one intersection area and this is another intersection area, and 1 is the minimum element. Okay, uncovered element. Okay, so here infinity 3 0 4, what, 4 0, then what, then there is 3 infinity 1 0 1, then 0 1 infinity 2 0, then 3 4 0 2 infinity 3, and this 0 1, since these are the uncovered elements, we subtract 1 from all the uncovered element and add 1 in this intersection. Okay, so 3 sorry, this is 0, this is 0, this is 3, and this is infinity. Okay, now we again apply the same process, that is what, we now draw the lines to cover the zeros. Okay, so if we write such that here 2 0, therefore we draw this line once. Okay, one line, then this is second line, you can say, just a minute. So this is line 2, no sorry, if we draw this line, then this is some are uncovered. Okay, this line is miss, this is 0. Okay, so this is one line, second line. Okay, and then 2 3 and 4, so there are 5 lines and the order of the matrix is 5. Okay, so this is this is the optimal solution. Now we find the assignments. Okay, so these are, we write only the zeros. Okay, so 0 0, this is 0, this is 0, sorry, this is not 0, 0 0 0, in here 0, I think, yes. So 0, last one is 0, then in the D the second one is 0, and then in the E this 0 and this 0. Okay, so we get 1 2 3 4 5 6. Okay, I think this is correct. Okay, now we choose the row in which contains only single 0. Okay, so in the second row there is a single 0, therefore we choose this. Okay, then in the fourth row there is a single 0, we choose this. Okay, now in the three rows, that is A rows, these rows, and these rows contains, each contains 2 0. Now if we go to the columns, this column contains 2 0, this columns also contains 2 0, this columns also contains 2 0. Now we since there are number of zeros in each rows and each columns are same, therefore we choose an arbitrary assignment. Okay, so suppose we choose this 0. Okay, so if we choose this 0, then this 0 goes to cancel corresponding to this row, and this 0 also goes to cancel corresponding to this column. Okay, now since if we go to this row, therefore there is only one 0 in this row, therefore we select this 0 and cross this 0, and also now in this row there is also 1 0 only. Okay, so this is selected. Therefore the optimal assignment is now what? A goes to C, okay, B goes to D, B goes to D, okay, B goes to D, C goes to E, C goes to E, then D goes to B, D goes to B, and E goes to A. Okay, so this is the assignment. A goes to C, B goes to D, C goes to E, D goes to B, and E goes to A. Okay, so this is an assignment. Okay, this solution see, one thing is that A goes to C, B goes to D, so A goes to C, C goes to what? E, E goes to A. Okay, so this here the loops ends. Okay, but this is not the traveling salesman, this is not the traveling salesman, this does not satisfy the traveling salesman problem. Because what? Because if we start from any row or column or any city, we go to the other cities and come back to this cities A, but here after before completing the all cities, it okay, come back to A, therefore this is not a traveling salesman problem. And now B goes to what? B goes to D and D goes to B, so there is 2 loop. Okay, so this is not the, this does not satisfy the traveling salesman problem. Okay, because we need only one loop such that all the cities will be covered. Okay, so this is not the traveling salesman problem, therefore we write now again the zeros. Okay, so this is 0, this is 0, this is 0 0 0 0 0, and there is also 1 0. Okay, to find the best solution beside all the zeros, we consider the next minimum cost. Okay, that is 1. So we write the next minimum cost beside the 0. So here the minimum cost is this one 1, this one 1, this one 1, beside 0 this one 1. Okay, so we write this minimum cost. Okay, so there is 1, there is 1, there is 1, and after this there is 1 1. I think there is 4 1. Okay, okay, now since this row there is no single row which contains, oh, there is a single row, just a minute. Okay, second so here fourth row contains only one element, so this fourth column contains only one single 0. Okay, therefore we can choose this 0 B here, this 0, which suppose choose this 0, therefore this goes to cancel and this goes to cancel. Okay, now this row contains a single 0, D goes to B, D goes to just a minute. Then we consider the next minimum cost, and that is 2 in table 6. To find the best solution beside all the zeros, we consider the next minimum. We observe from the table 5 and the second and fourth column have only one element. Okay, so we choose this 0 here. Now after choosing this 0, what? B goes to G, D goes to B. See, one thing is that here the assignment is B goes to D. Okay, now since in the fourth row there is a 0 in D only. Okay, so if we choose this D goes to what? This D goes to B, then this is also not satisfy the traveling salesman problem. Okay, because this is a one loop, but in the loop all cities does not covered. Okay, so B goes to D, D goes to B is not chosen. Okay, so we write the next minimum cost beside the 0, that is 2. यहाँ पे 2 को भी लिखना होगा, ठीक है. This is a problem. Okay, so see the problems. We again write the next minimum cost. Okay, so see why we write this, because देखो यहाँ पे ये B D पर जा रहा है, ठीक है, क्योंकि यहाँ पर ये जो कॉलम है यहाँ पर ओनली सिंगल एलिमेंट है. Now we see that in the for the fourth row there is a single 0 and the assignment goes to D, this D goes to B and this B goes to D. See, this occurs, B goes to D and this D goes to B. Okay, B goes to D and D goes to B. Oh sorry, I think it is possible, right? So just a minute, we write, so this D goes to B, if we write here. Okay, now this one cancel and this one cancel. Okay, now since these two are cancel, now we go to the next. So there is 2 0, there is 2 0, there is also 2 0. In the column there are 2 0, in the column there are 2 0, in the column there are 2 0. ठीक है, तो यहाँ पर नेक्स्ट मिनिमम कॉस्ट तो लिखना ही होगा. ठीक है, 2 जो है नेक्स्ट मिनिमम कॉस्ट है. ठीक है, यहाँ पर सी वी राइट 2 हियर and 2 here, also there are no 2. Okay, so ये यहाँ पर करना होगा. ठीक है, जो ये जो हो गया 2 2 2, तो नाउ इसका इस बार असाइन करना होगा. देखो एक बार प्रॉब्लम हो रहा है यहाँ पर. ठीक है, सी यहाँ पर 2 0 है, यहाँ पर भी 3 एलिमेंट है, यहाँ पर 2 एलिमेंट है. ठीक है, तो नाउ यहाँ पर एक को चूज करते हैं. ठीक है, ए गोज टू सी, सपोज इफ वी चूज ए गोज टू सी, देन दिस कैंसिल, दिस कैंसिल, दिस कैंसिल. ओके, सो ए गोज टू सी and now if we go to this column. Okay, so there is only 2 elements, so suppose this is chosen, therefore this is cancel, this goes to cancel. Okay, and one assignment only need in this. Okay, so this is assignment. देखते हैं ये यूनिक होता है कि नहीं. ठीक है, नहीं तो फिर से करना होगा इसको. देखो ये पूरा के पूरा ट्रायल एंड एरर मेथड. ठीक है, इसको ऐसे ही करना पड़ेगा. सो ए गोज टू सी, ए गोज टू सी, सी गोज टू ए गोज टू सी, देन क्या है, तो सी है डी पर जा रहा है. ठीक है, ए गोज टू सी, ये भी ये होगा, ए गोज टू सी, बी गोज टू डी, B goes to D, C goes to D. सॉरी, 2 असाइनमेंट हो गया यहाँ पे, ये थोड़ा प्रॉब्लम हो रहा है. ठीक है, इसको रेज करते हैं. ठीक है, जीरोस को लिखते हैं फर्स्ट. जीरो 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 and this is also 0. Okay, so see and ones को भी लिखते हैं. ठीक है, and 2 को भी लिखते हैं. ठीक है, this is 1, this is 1, this is 1, this is 1, this is 2, this is 2. ओके, नेक्स्ट 2 मिनिमम कॉस्ट को हम लोग यहाँ पे लिख लिया. ठीक है, नाउ ए को सी पर डालते हैं. देखते हैं क्या होता है। ए को सी पर डालो, ए को ई पर डालो, ठीक है। ये ट्रायल एंड एरर मेथड हो रहा है, ठीक है, और प्रॉब्लम हो गया। ए को ई पर दिया, दिस गोज टू कैंसिल, दिस गोज टू कैंसिल, दिस गोज टू कैंसिल, ठीक है। देन ए गोज टू ई, बी में यहाँ पर 2 एलिमेंट है, 3 एलिमेंट है, 2 एलिमेंट है, 3 एलिमेंट है, ठीक है। तो देखो ई को बी यहाँ पर 2 एलिमेंट है, दिस कॉलम में 2 है, 2 है, 3 है, 1 है। बी को, सो लेट अस चूज अनदर, बिकॉज यहाँ पे कोई भी रो एंड कॉलम में सिंगल एलिमेंट नहीं है, ठीक है। देयरफॉर बी को चूज करते हैं डी पार्ट, ठीक है। सिंस यहाँ पर मीन नंबर ऑफ एलिमेंट्स इन दिस रो इज मिनिमम, देयरफॉर वी चूज this one. Okay, this is just choose. Okay, this is not the unique solution. Okay, so I just choose here, so this is goes to cancel, this goes to cancel. Okay, now there are also 2 element, 2 element, 3 element, therefore we choose either this row or this row. Okay, so D goes to, if we choose this C, okay, C को डालते हैं यहाँ पर ई पर, दिस गोज टू कैंसिल, दिस कैंसिल, दिस कैंसिल, एंड इन दिस जो रो है यहाँ पर भी 2 एलिमेंट है, सिंगल एलिमेंट, तो ये चूज हो गया, ये कैंसिल हो गया, एंड ये चूज हो गया। तो क्या यहाँ पर आया आंसर जो है, देखते हैं क्या आया। दिस इज ए कंफ्यूजन। सो ए गोज टू ई, इसको भी कैपिटल में भी लिखो, ए बी सी डी ई। ओके, तो देखो ए गोज टू ई, ई गोज टू ए, तो ये ओके ओके ओके, ए गोज टू ई, ई गोज टू व्हाट, यहाँ पे भी प्रॉब्लम आ रहा है, ठीक है। यहाँ पे भी प्रॉब्लम आ गया थोड़ा। दिस इज द सेकेंड मिनिमम कॉस्ट। Okay, so if we write this assignment, A E, ये एरर हो रहा है, ठीक है, मेरे को, मुझे कोई बात देखने दो क्या हो रहा है। B D C, तो if we goes A goes to A, therefore this we assign A to A, this goes to cancel, this cancel, this cancel. Okay, E goes to, suppose there is 3 element, 2 element, 3 element, so we choose arbitrarily. Okay, B यहाँ पर 2 एलिमेंट है, तो B को D में डालते हैं, ये कैंसिल हो गया, ये कैंसिल हो गया। C में 2 ही चॉइस है, ठीक है। B, if we choose C goes to B, but B I think not assigned now. If we see A goes to E, B goes to D, C goes to E goes to E, C को 2 ही चॉइस है, ठीक है। देखो C goes to B और C goes to A. If C goes to B, then this goes to cancel and this goes to cancel. B goes to C, ओ ये लूप नहीं फॉर्म करेगा, इसलिए इसको C को B में डालो, C को A में डाल रहे हैं ये लोग, एंड D को, तो ये गोज टू कैंसिल हो जाए, ये कैंसिल हो जा रहा है, D जा रहा है C पे, कैंसिल कैंसिल, E जा रहा है B पे, ठीक है। तो ये ऑप्टिमल असाइनमेंट यहाँ पे आंसर जो दिया है बुक में, ठीक है, ये एक आंसर दिया है, ठीक है, बट आई थिंक देयर इज ए प्रॉब्लम. ओके, so you can check once this problem, you can do these problems by your own, okay, and see it why, what is the problem. Okay, this is the answer given in the book, but I am not applying the books, मतलब thoroughly books में जो है वो मैंने यहाँ पे अप्लाई नहीं किया. ये जो लाइन्स है ये मैंने बुक से थोड़ा अलग कर दिया, ठीक है. तो ये थोड़ा गड़बड़ हो रहा है मेरे को लग रहा है, ठीक है. तो आप लोग एक बार देख लेना ये कहाँ पर गड़बड़ हो रहा है एंड मेरे को ये कमेंट सेक्शन में बताना, ठीक है. तो इसका जो आंसर है देखो, इफ ए गोज टू ई, जो असाइनमेंट का आंसर होगा ए गोज टू ई, दैट मीन्स दिस इज 1, ए गोज टू ई जो है, जो ऑप्टिमल कॉस्ट क्या हो रहा है, मिनिमम कॉस्ट, ठीक है, जो मिनिमम कॉस्ट हो रहा है देखो यहाँ पर ए गोज टू ई, ठीक है. तो ए गोज टू ई मीन्स जो आंसर हो रहा है ये इसका, ठीक है, 4 + 6 + 5 + 9 + 6, इसका 30 आंसर होगा. आप लोग एक बार चेक करना, ठीक है, क्योंकि यहाँ पे थोड़ा गड़बड़ हो रहा है, लग रहा है मुझे को ये प्रॉब्लम. यहाँ पर भी ये लोग 2 लूप लिया है, ठीक है, एक में 31 आंसर आया है ना, एक में 30 यूनिट्स आंसर आया है ना. ये लोग इस बात का चूज कर रहे हैं, मतलब यहाँ पे पूरा के पूरा ट्रायल एंड एरर मेथड की गेम है, ठीक है. जो देखो जब ये लूप नहीं फॉर्म करेगा, मतलब 2 लूप अलग अलग लूप फॉर्म करेगा, तो क्या होगा, वो ट्रैवलिंग सेल्समैन प्रॉब्लम नहीं बनेगा, ठीक है. तो ये इसका प्रॉब्लम है एंड आप लोग एक बार देख लेना यहाँ से अच्छे से, ठीक है. मेरे को भी थोड़ा गड़बड़ लग रहा है और एक प्रॉब्लम आई थिंक लेकर डिस्कस कर लेंगे हम लोग, ठीक है. तो इस वीडियो में इतना ही. इफ यू लाइक द कंटेंट देन प्लीज गिव लाइक टू दिस वीडियो, शेयर विथ योर फ्रेंड्स एंड सब्सक्राइब द चैनल. थैंक यू, सी यू अगेन इन द नेक्स्ट वीडियो.